Hello guys, hope you're doing good. If you're new to this channel, please subscribe the channel. I upload videos on Java programming technologies and application development. So today we are going to see how to write a Java program to check whether a number is an Armstrong number or not. Okay. Let me name the class as Armstrong check. I am using IntelliJ IDE. If you are using Eclipse or BlueJ or any other ID, that's not a problem. That will do the fine. Okay, now let me first brief you about what is a Armstrong number. Armstrong number is such a number. If we extract the digits of the number and make cube and add the cube of each of the digits, then we get the original number. The sum of the cube of the digits is equals to the original number. That is the condition for Armstrong number. Now in the program, we are actually using a main method, public static void main. This main method is the entry point of our class because it's the heart of our application. If we run the class as a Java application, then it should have a main method. Now suppose I am taking a input from the console. I would be using buffered reader. Okay, that's fine. First I would take an input from this method, main method, and I would pass it over to a method that would check and return me a boolean output. If it's a Armstrong number, it would give me a true output. If it's not a Armstrong number, not an Armstrong number, it would return a false. So let me name the function as Armstrong check. I would input a number and I would check whether it's Armstrong or not. So let me take a flag variable that initially is false, and let me take a backup of the original number inside another variable, say b. Now let me run a while loop on the backup number. Why I'm taking a backup, that you would understand why I am taking, and another variable I would take and insert it initialize it as 0, because this would be the variable that would store the sum of the cube of the digits. So in R, we are actually basically what we are doing, we are dividing it by 10 and storing the remainder. And in S, what we are doing the summation of the cube of the remainder. These remainders are the digit that is extracted from the number, and we are updating b equals to b by 10. Fine, well and good. This loop helps us to obtain the sum of the cube of the digits. Now we would check that if this sum is equals to the original number, then oh my gosh, it's a Armstrong number, so f equals to true, and by default f would be false. So if it's not an Armstrong number, so we would return f, and f is false by default, so false would be returned. If we uh, check and see that it's not an Armstrong number. Okay, fine, this is the code for our Armstrong number, and let us write the main method. By the time I would copy it, because it's the same piece of code that is we have to write. Let me connect my charger, please give me a minute. Okay, so now I am pasting the code here. Yeah, one minute. What's the problem? We have to add throws IO exception, and the method name is Armstrong check. If it's Armstrong, we would print as Armstrong, and if it's not Armstrong, we would print not Armstrong. Well and good, we are done with the check. I'm going to make it static, because static members can only call a static member. So it's a static member, so we have to call another static member only. And this input is a integer. So we have to read a integer. We have to convert it, parse it to a integer. Well and good. This is also integer. Now that's fine. Just let me give it as int. That would do. So let me run the application and then I would do the dry run. Okay. Now I am running the main method of this class, Armstrong check. It's building. Just in a couple of minutes it would run in the console. Okay, we are here. Suppose I give 153. It's an Armstrong number. And let me check with another scenario where it's not an Armstrong number. Suppose I give 789. It's not Armstrong. So now let's dry run it and check if we give the input as 153, what is the output. For dry running, I would run it here in the notepad and I would show you the dry run over here. I would keep it here. Suppose the input number A is equals to 153. Now, if you are not aware that what is dry run means you think yourself as a compiler and check line by line what the code is going to execute. Now, the first line that is going to execute is f equals to false. So f would be stored as false. B would be assigned as 153 because A's value is 153. So 153 will be stored in B and A's will be initialized with 0. So till now, before the loop, we have been we are in this state where f equals to false, b equals to 153 and a equals to 0. And in the while loop, the condition starts that whenever the b value is greater than 0, I would enter the loop. So b is greater than 0, so I am entering the loop. This is my first iteration. When the first iteration, the first line is r equals to b percentage 10, means 153 would be divided by 10 and the remainder would be stored in r. Percentage or the modulo operator returns the remainder. Okay, the modulo operator returns the remainder and the by slash front slash operator or the divided by symbol returns as the quotient. Just a point to remember, the percentage symbol returns the remainder. So what is the remainder upon dividing 153 by 10 is 3. We get a remainder of 3. Now in s, what you are storing, s equals to s plus, means the original value of s is now 0. So 0 plus r into r means 3 into 3 into 3. So we get 27 now stored in s, and b's value is updated by b equals to 153 divided by 10. The current value of b is 153, so 153 by 10 we get 15. The quotient returned by dividing 153 by 10 is 15. So now the value of b is 15. Now again, in the next iteration, we are checking the condition first. If it holds good, then we would enter the loop. The value of b is 15 now. So 15 greater than 0. Yes, it's true. So we would be entering in the loop. We are inside the loop now. The first line of the loop executes and r will be equals to b percentage 10. Means 15 percentage 10. The remainder returned is 5. So r will be initialized with 5 now. Assigned as 5. Now s will be equals to s plus. What is the value of current value of s? The current value of s is 27. So 27 plus the remainder that is obtained in the previous state is 5. So cube into 5 into 5. The output would be 125 plus 27. It's 152. Okay, it's 152. And b would be initially assigned as b equals to b by 10. What is the current value of b? Current value of b is 15. So 15 by 10, we get the quotient to be 1. So now the value of b is 1. So now we are again checking the condition that b value is 1. b is greater than 0. Means 1 is greater than 0. Yes, true, it holds good. So now we would be entering in the iteration, last iteration. Is the last time the loop would be executed. Now what's the value of r? R would be equals to b percentage 10. What is the value of b? B is 1. So 1 percentage 10 returns the remainder upon dividing 1 by 10. So what is the remainder? The remainder is 1, because 10 does not divides 1. So 1 is returned as a remainder. So r equals to 1. And s would be equals to s plus. What is the current value of s? Current value of s is 152. So it's cumulatively adding 152 with 1, that is R is 1, so 1 into 1, so we get 153. So now the current value of A is 153 and the final value of B is B by 10, means 1 divided by 10. The quotient returned after dividing 1 by 10 is 0 because 10 does not divide 1. So 10 zeros are 0, that would be the division's process. So 0 is the quotient in this process. So next, in the next step again we check the condition first, b greater than 0, but alas the value of b is 0, so 0 is not greater than 0, so the loop gets terminated here. So no more, the loop would be terminated. So now after the loop the statement is if s equals to a. Now we will be checking the equality of s. What is the value of s? S is 153. And what is the value of a? Original value of a is, we started with this line, that means 153. So the if condition is checking that if 153 equals to 153, that means it's a true. So true means it would be executed, the statement after if would be executed, that is f equals to true. So we are assigning a true constant in true literal inside f variable, so we would be returning true then. And if this condition does not hold good, that means it's not a Armstrong number, so this line would not be executed, that means f would be stored as false and f would be returned as false. Hey guys, thanks for watching and please do subscribe if you're new to this channel. Meet you in the next video.